Hello everyone, this is Lian Marie Barangco of PSECE 3C, and for Communications 2 or ECE 23, we're going to discuss arithmetic coding for performance task 9. So arithmetic coding including the encoding and decoding. So our given is 2018-61908, where A is going to be the EOT or the end of transmission mark. So next is we're going to find the probability of each variable. So the probability of number 2 is 1 out of 10, which is equivalent to 0.1. The probability of 0 is 2 out of 10, which is equivalent to 0.2. And also 1 has the probability of 2 out of 10, which is also equals to 0.2, and the remaining variables, which are 8, 6, 9, and A, has a probability of 1 out of 10, which is equivalent to 0.1. So this is the arrangement of the variables in chronological order based on their equivalent. So here we are going to encode 20186198. So the first variable is 2. 2 ranges from 0.9 and 1.0. So the difference between the variables is 0.1. However, in variable 1 and variable 0, they has probability of 2 out of 10, so the value of their ranges is doubled compared to the other variables. The difference is 0.01 in this section. Next is 0. 0 is from here up to here. So the range of its value is 0.92 and 0.94. So we're going to expand this and then input the equivalent datas. Next is for variable 1. So the range is from 0.92 up to 0.924. And the difference in here is 0.0004. And next is the variable 8. So the value of variable 8 ranges from 0.9232 and 0.9236. We're going to expand this, and the range in here is 0.00004. Next is we're going to encode the dash at the range of 0.92348 up to 0.92352. So we're going to expand these values and eventually get the difference, which is 0.000004. So the next value is 6 from 0.9230504 up to 0.92358. So the difference from these two values is obviously 0.000004. However, that value is we're going to divide it by 10 because our data here is 10. So now the difference from this is 0.000004. Next is 1. So we are at this part of encoding already. So 1 is from the bottom part. The value now ranges from 0.923504 and 0.9235048. New difference or delta 0.0000008. Next is variable 9. So variable 9 ranges from 0.9235044 up to 0.923504448. So finding its difference from each levels, that would be 0.00000008. Next is the variable 0, and it ranges from 0.9235044416 up to 0.9235044432. So by expanding these values, its difference would be 1.6 times 10 raised to negative 9. Lastly is encoding the end of transmission mark, which is A, and the value ranges from 0.9235044224 and 0.9235044424. So this is going to be our lower bound and this is our upper bound. Since this is the mark or the end of transmission mark, we're going to stop encoding here. Since we have the values from our lower bound and upper bound, we need to find the value of the middle bound. And it is based on the average between these two values. So the average would be 0.9235044232, and this is in decimal value. Next is we're going to convert it to binary. So the binary conversion is this. And this is the equivalent code for our data 2018-61908. And for decoding and checking for the results, we need to convert the binary value back to decimal. So this is the decimal conversion of our binary value. So this is approximately equal to our middle bound based on our previous calculations, but it doesn't matter as long as it is between the ranges of our upper bound and lower bound. So the average bits per symbol in here is 60 over 10. So that would be 6 bits per symbol. And for decoding or for checking for the values, it is very easy. We're just going to look at the where this value is in. So obviously 0.9235 is between this range, which is equivalent to number 2. So we're going to find where this value ranges again. So it is between 0.92 and 0.94. So that is equivalent to 0. Next is 0.92 and 0.924. So it is in variable 1. Next is finding its value to the next set of numbers. It is between 0.9232 and 0.9236, which is equals to variable 8. So it's correct. And next is for its value, it is here in 0.92348 up to 0.92352. Next is, this is decoding. So finding its value, it is between here in 0.9235 and 0.923508. So it is equivalent to number 6. And so on and so forth. So we concluded that this is the lower bound and the upper bound by decoding our data. So for summary, arithmetic coding or AC is a form of entropy encoding used in lossless data compression, and it encodes an entire file as a sequence of symbols into a single decimal number. EOT stands for end of transmission, which is also known as end of file and end of message. Decimal value must range between upper and lower bound values. And that's all. Thank you.